We're now going to do absolute value inequalities. So we'll refresh our mind with the equation absolute value of x is 3. This is telling us that the distance from 0 is exactly 3 units. If we're going to graph this, it means on the number line we have 0. If we go 1, 2, 3 units to the right, we're at the exact point of positive 3. 1, 2, 3 units to the left, and we're at the exact point of negative 3. So when the distance from 0 is exactly 3 units, we get two values, positive 3 and negative 3. Now we're going to change this to an inequality. I'm going to say the absolute value of x is less than 3. If I write what this is saying that the distance from 0 is less than 3 units. So that means the distance from 0 on both sides, to the right or left, are less than 3 units. Well, we put up our number line, and we know at 0, 3 units to the right is positive 3, 3 to the left is negative 3. When the distance is less than 3 units, it means it's up to but not including the 3, and the same on the other direction. So you're less than 3 units to the right, less than 3 units to the right, less than 3 units to the left. And because it's not going to include the endpoint, that means it goes up to the 3 but doesn't include it, and it goes down to the negative 3. Everything from 0 to 3 is less than 3 units, and the same on the other side. So this tells us that our solution for this is the interval from negative 3 to 3. When you see this less than symbol, that's going to tell you you have an interval. Let's extend this with another kind of problem. So for example, suppose I say solve for x, and I say the absolute value of 2x plus 1 equals, not equals, is less than or equal to 9. For this one, the shortcut I'm going to show you, just like up here, I just had identified the 3 and the negative 3. Once I identify the endpoints, I'm going to know that this is an interval. So I have 2x plus 1 is 9, or 2x plus 1 is negative 9. I'm going to set up the x values for that. Solving this, I get 2x is 8, so x is 4. Subtracting 1, I have 2x is negative 10, so x is negative 5. I'm now going to put my number line, and I'm going to put the two values where the absolute value would equal 9. I'm going to put them on the number line in the correct order. So coming from the left, the first value is negative 5, the next is 4. So because I have a less than here, I automatically know that I have an interval. And it's going to be the interval between those two x values. Now, because there was an equal, instead of an equal sign, instead of it not including the endpoints, it's going to include the endpoints. So my solution for this inequality will be all the values from negative 5 to 4. It is that interval, and that's the solution. Now this was, anytime we see, if we go back here, we see a less than, that's telling us it's an interval. Now what we're going to do is we're going to now look at what if I had said absolute value of x greater than 3. Going back to the original description of absolute value as distance, this is saying that the distance from 0 is more than 3 units. We know from what we did originally, absolute value of x being equal to 3 units, we go from 0 and we go 1, 2, 3, and 3 in the left direction, negative 3. So if the distance is more than 3, I go up to 3 and then it's more than it, it's going to be out here to the right. Or if it's more than 1, 2, 3 this way, it's out here to the left. And because it's greater than, it's not going to include the 3. What we get when we have the greater than sign is we get what are called two rays. We get two shaded regions. And I can write this as negative infinity to negative 3 union 3 to infinity. I'm showing that I have two rays, two separate results. So once you see the greater than, that automatically tells you you will have two rays. So wherever your results for the absolute value equals, you're going to be in the outskirts of those. So now then I'm going to do that same problem we just had, only now I'm going to say solve for x. Absolute value 2x plus 1, this time greater than 9. So this problem, just like the less than or equal one, everything hinges not on the inequality signs, but everything hinges on setting up 2x plus 1 equal to plus or minus 9. So just like I did before, I say the inside 2x plus 1 is positive 9, or the inside 2x plus 1 is negative 9. We had already spent time solving these. If you recall, we subtracted 1. We got 2x is 8, so we have x is 4. Then here we subtracted 1. We get 2x is negative 10, so x is negative 5. Now I've circled these. They're not our solutions, but they are the 2 points on the number line that we're going to identify. Now we put the number line and we put the two values that we got, setting the absolute value equal to the number, and those two values go from left to right, negative 5 and then the 4. Looking at this, because this is greater than, I know I'm going to have two rays, and the two rays go in opposite directions. So clearly one ray goes from negative 5 out and the other from 4. Because it's strictly greater than, it doesn't include the two values. And now we write as our solution, writing from the number line from left to right. This first one is negative infinity to negative 5, and then we put the union sign because that's showing we have another solution, which is 4 all the way out to infinity. So that would be the solution of that absolute value inequality. So now we'll create a rule that's going to help us. So if I say the absolute value of box is less than triangle, the way we'll work this is we'll set box equal to triangle or box equal to negative triangle. We then would solve these for x, y, or whatever, and we're going to get two values. Let's say one is a and the other is b. Because it's less than, that tells me it's got to be an interval. Less than means an interval. So the minute we see less than, everyone, we know it's an interval. And that's all we have to do. We never have to use less than again. We know it's going to be an interval. And so our solution would be, we'd say SOLN, the solution would be A to B. I'll call this our first grid, teaching us how to do this. Our second one is if I say absolute value of box greater than, let's say greater than or equal to triangle, I'm going to have the same number line because I will have solved box is triangle, or box is negative triangle. I would have solved these and gotten the same two values, A and B. Now, because it's greater than, I'm going to shade in the 2 rays. And that's just always what it is. And because of the equals, it's just going to go with brackets. So this tells me they're going to be 2 rays. And the solution